out of your Kubernetes clusters to kind of recoup that investment, then you have slices of a CPU and you'd like to boot relatively quick, but you're doing it on a slice of a CPU, right? So these are the challenges. So what Red Hat did is we went out and we said, well, let's rethink how we develop with Java. And basically the result is Quarkus. And so, what you see here, and you'll learn more about Quarkus. So, don't worry much about APIs and all that kind of stuff right now. But what you see is if you're developing with a traditional cloud native stack, right? Think Thorntail or Wildfly Swarm if you've used that from Red Hat, or Dropwizard or Spring Boot or something like that, right? Traditional cloud native stack, and you're using roughly just for a RESTful endpoint, 136 megabytes of RAM. And that's not the heap size, that's the entire size of the process in memory, okay? So it's the resident set size. If you run that same RESTful endpoint application on Quarkus, it's roughly half that. And if you compile it down to a binary using Oracle's GraalVM, thanks Oracle, you can get it down to 12 megabytes of RAM resident set size footprint, right? So extreme density. And now if you look at startup time, this time we'll look at maybe the bottom row where you have a RESTful application with a CRUD endpoint, right, talking to a database. Again, you go from 9.5 seconds for traditional cloud native stack down to roughly 2 seconds on top of the OpenJDK. Or if you want to take that app and compile it down to a native binary, it'll boot in about 42 milliseconds, right? So we're gonna, I'm gonna be developing an application throughout kind of this session, and depending on how far I get, we'll see, and how long folks want to stay on and how much they want to see. But basically, I've also pre-compiled this to a native binary, what I'm going to demonstrate. And I did that because I figured with live streaming and the CPU churn it's going to take, along with the amount of time it could take, compiling down to a native binary can take, minutes. So I pre-compiled the application and it's already running in the cluster, right? All right, so that gives you a little bit of an idea about one of the reasons why we also, why we kind of created a new runtime in Quarkus. Okay, we're recording now. Excellent, pressure's on. Okay, the other thing that we focus on, or something else, is developer joy. So the developers started thinking, well, if we're going to kind of rethink Java in developing microservices or maybe even serverless and functions as a service, right? What can we do to make developers as productive as possible, right? Again, Java has competition, especially on Kubernetes because of footprint. So what we want to do is have the productivity of dynamic languages, right? Basically being able to make changes and not have to go through that long cycle that we're all familiar with. We've got to build/compile into a Java jar file, run it, and then kind of refresh the browser. It's not necessarily all that fun. So the nice thing about Quarkus is we can just do live coding. Everything that we do is live and changes on the fly. And I'll be showing that. Another thing Quarkus does is unifies the imperative and reactive models all on the same stack. So by imperative, I mean, think traditional JAX-RS style, thread per request type development, blocking calls, or you can do async reactive from the very core, whether you have a RESTful endpoint using a reactive routes library that Quarkus has, or if you are doing something like Kafka streams, right? The entire thing can be async, and it all runs on a single stack. So under the hood, the stack is basically, you got the Java networking, then you've got Netty, right? Pretty much everybody I think has Netty these days. Then you've got Vert.x, Eclipse Vert.x. So if you're familiar with Vert.x, it is basically, it was originally created to be like Node.js for the JVM, right? It has an event loop like Node.js does, except that it has one per CPU core. So you get, multi-event loops, really cool stuff. And that's under the hood of Quarkus. And then on top of that, we have Undertow as a servlet container. So really, Undertow layers on top of an async engine. Same thing with REST Easy as our JAX-RS RESTful framework. JAX-RS framework also layers on top of Vert.x by default. So you can do a lot of async style development, and but just keep in mind, if you're using the traditional, Java EE or Spring APIs, it tends to block, right? It is blocking APIs, but it's pretty cool. And then you could use a single runtime and use either within your organization. You could do either within the same application or both. And you could probably do both inside the same Java class if you want to. Why you might want to, I don't quite know, but you can. All right. Now, when we think about Quarkus and the APIs that it supports, so Quarkus supports quite a few APIs. I'll give you an example when we start generating an application, kind of scroll through a larger list, but you probably recognize some of these logos, right? MicroProfile, some Java EE JSRs. So I already mentioned JAX-RS. You get CDI, you get Bean validation, JPA and Hibernate, Apache. You also get Apache Camel, support for OpenShift and Kubernetes, Prometheus, right? A lot of the kind of Kubernetes open standards or APIs in some cases as well, Jaeger and so on. So there's quite a bit of support for frameworks within Quarkus. So when we first launched Quarkus, we basically had, I think, 38 extensions, and I'll explain what an extension is a little bit later. But think of an extension for now as just a Java, a Maven dependency, and it's a Java framework. Right, so think of like CDI as a framework, right? So we had 38. Sorry, I am hearing a little bit of background noise. Extensions. Today we're over, or roughly about 250. So half of those are Camel and Camel extensions or connectors for connecting to back-end systems for enterprise integration.
Trying to make sure.
Okay, thank you.
All right, John, I'm just muting people.
Got it, I understand. I host a MicroProfile live hangout, and occasionally we have to do the same thing. So now that gives you kind of this foundation, this baseline understanding of what Quarkus is, right? It supports a lot of Java frameworks. It's very efficient at runtime, supports reactive and imperative APIs. But the reason why I chose this title is because of a tweet I saw the first few days after Quarkus was released. Quarkus feels familiar and new at the same time. And to me, that was a huge compliment. It's kind of a hat tip to the engineering team for kind of coming up with Quarkus. And so I've never really approached presenting Quarkus this way, but I thought I'd give it a try to you folks. And as a little bit of a disclosure, the person that tweeted this was a Red Hat employee, but they had nothing to do with Quarkus. So they were really just another user out in the Java enterprise framework user sphere. And they kind of came up with this. And I never forgot about it. And this is the first time I'm trying this approach. So rethinking what we already know. Well, that begs the question, what do we already know? And so this is going to be a theme throughout the next set of slides. It supports, or not supports, but what we already know is Spring, right? This kind of came from, for those on the recording, we kind of had some informal polls before we started recording, and folks listening have experience with Spring APIs, Java EE, and you can see I kind of replaced Jakarta there because it is really Jakarta EE today. Eclipse MicroProfile, maybe you know Vert.x, right? Maybe you know some of those other frameworks I've mentioned. These are things that we already know, and when we develop applications, we want to bring and adopt new runtimes. We want to bring forward the APIs and skills that we already know and have built up. So this is just a very simple example, right? So on the left-hand side, you have a Java EE plus MicroProfile style application, right? And this is color-coded. So you see the Java EE related APIs in red, and you see the MicroProfile related APIs in blue, right? On the right-hand side, you'll see the Spring APIs, right? these don't get too concerned about the actual source code. You're not going to compile it and run it, but it's just to get the idea across, right? That you've got, this built-up experience in the Java enterprise developer ecosystem. So what's interesting is that with Quarkus, it supports a lot of the APIs you already know. So if you look at the left-hand side, this is just a subset, I didn't try to be complete, of the Java EE related APIs that Quarkus supports. Quarkus is not Java EE compatible, nor does it ever intend to be, right? It's really targeting specifically microservices. It does, however, support all of the MicroProfile specs, and it supports a subset of Spring APIs, right? So you can kind of see some of the frameworks and topics, I guess, functionality that it supports. And there's a couple more I didn't list as well. Quarkus has its own set of APIs that are native to Quarkus. So there's reactive routes. And I might be able to have just a little bit of time to show you just a tiny piece of that. But basically, if you use JAX-RS, it's a blocking API, but reactive routes is not. But you still get that familiar annotation-based approach to developing RESTful endpoints. Qt as a templating framework. So you can template out a UI using Qt, so it's server-side rendering. And it's templating. So you could, if you serve up HTML and some JavaScript, it will do the replacement on the server side, but then it's local in your browser. Support for Hibernate and for JPA and MongoDB, and there's also what we call a with panache kind of lingo, and that adds ease of use capabilities on top of existing frameworks. So we have a Hibernate ORM with panache and a MongoDB with panache framework. So again, it's basically the frameworks, those two frameworks that you know, but it has an ease of use kind of layer on top of it. Of course, Quarkus didn't write Eclipse Vert.x, but I just want to reiterate that Eclipse under the hood uses an awful lot of Vert.x, and Vert.x is blazingly fast, right? So if you've got experience with Vert.x, just know it's under the hood, kind of serving up some of this reactive stuff that you're seeing here. And there's also a reactive framework called Mutiny. Think of it as RX Java or Reactor in terms of the functionality it provides, but it tries to be much more developer friendly about it. So if you say, for example, stream dot, you don't get 500 method options, right, to choose from. It tries to be a very what's the word? I can't remember the word here, but fluent kind of builder pattern API that makes it very easy to use. So there are some presentations out there on Mutiny if you're interested. And there's other frameworks that Quarkus supports that doesn't necessarily fit that any of these kind of topics, right? They're just generic frameworks out there, and you can see them listed here, right? Quartz, gRPC, and I've already talked about some other ones. Okay, so what's really neat is that you can combine all of these things. So you can combine Java EE with MicroProfile with Spring APIs, all in the same application, or as you can see here, even in the same Java class. So just a bit of note, what we do with Spring APIs is we don't take the Spring ecosystem jars and just run them on Quarkus. So Quarkus has to do an awful lot of work to get all of these frameworks I've been talking about running very efficiently and running on top of Graal VM. And trying to do that with the Spring APIs would just take too long, and we kind of took a different approach. Because what we're not necessarily trying to say is rehost your existing Spring apps on top of Quarkus. The idea is you can pick up Quarkus with some of the things we're going to talk about, the benefits that Quarkus provides, but leverage the APIs that you know, right? So you don't have to start from scratch and learn a new API, whether it's the reactive APIs or the EE or MicroProfile. You can also use Spring APIs. And the way we do that basically is we map Spring capabilities, annotations, for example, to the equivalents that Quarkus already supports, right? So auto-wired under the hood gets mapped to inject, right, for instance. And there's also some glue code into some of these as well. So you could use the existing APIs that you know. So the benefits basically is, of course, begin with what you know. It eases you into everything else that Quarkus offers. So you can pick it up and start using it pretty quickly. And you can drop Quarkus into existing environments. So there were a lot of Spring developers. If you're running, for example, in your environment, the Spring Config server, Quarkus has a Spring Cloud Config server client. So you can basically pull your configuration from the Spring Cloud Config server from Quarkus, right? So that's kind of nice. And it even supports Spring Boot properties as well. So at config properties. And if you want to, you could maybe veer more towards specifications. So MicroProfile and Java EE really at the end of the day are specifications, right? And you can pick off the specifications that you want to use. You don't necessarily have to use the entire platform. And Quarkus is an example of that. It supports some of the APIs in Java EE, but not all of them. And what's really nice about specifications is Quarkus, when it was first released, used the MicroProfile configuration, the MicroProfile implementation of fault tolerance. So think circuit breakers, bulkheads, timeouts, stuff like that. And under the hood, the implementation was Hystrix, but Hystrix has been deprecated. So we had some options. We can go out and layer, fail-safe underneath. That's actually what Open Liberty does. Or what we decided to do was rewrite these ourselves so that it also ties into the async stack that Quarkus has, right? And so we re-implemented, but the nice thing is with specs is that developers' applications didn't break, right? They can use the same annotations and the same configuration properties and stuff like that, and it all still works. So that's the benefit of specifications. Okay, so let's take a pause here and see if I can go to code.quarkus.io. Oh, hey, we got Peter here. Hey, Peter. Let's see,
Hey,
Cloud.
nice to see you. Been a long time.
Yeah. Well, you see me, but I don't see you yet. So,
I'll pop on at the end and do the introduction in the reverse because
all right, there we go.
I didn't want to stand in your way.
Thanks, Peter.
No problem.
All right, so let's take a look at code.quarkus.io. So pretty much every modern runtime has some form of a starter web app, right? Pivotal in the Spring community started it, and everyone else just adopted it because developers really love it, right? So with Quarkus, we have our own. Everything that you see me doing here, you can also do from the command line just using a Maven plugin, right? So what I'm going to do here is just show you the UI way of doing it. So code with Quarkus. So you have your normal things, for example, Maven coordinates, and I'm just going to call this sfjug, right? That's going to be the artifact that we're going to work with. You can use Maven or Gradle. I'm going to use Maven for the Gradle folks, sorry. I don't know Gradle. Okay, so we're using the most recent version, which is 1.7.0 final. That was released, I think, a week or a week and a half ago. And now if you look at all of the extensions, again, just thinking of an extension for now as a Java framework that's been optimized for efficiency and unified configuration through a single config file and stuff like that, right? So it's just a Maven dependency for Java. All right, so you can see we have a whole bunch of web extensions, data and database extensions. You can see some cloud things like Amazon, and you'll see Google Cloud Platform extensions as well. Messaging, logging, reactive, a good chunk of reactive extensions. Cloud-related ones, that's where you'll see things like the Kubernetes extensions, observability with metrics and open tracing, a bunch of security, a ton of Camel, right? If you need enterprise integration, just a ton of them. And I'm still scrolling. Okay, business automation with business rules. You've got various serialization, a bunch of miscellaneous ones, and what we call compatibility. And this is where we have our Spring APIs. And I'll show you that in a second. And we have Kotlin and Scala support. Kotlin is, fairly far along, I think. It's not 100%, but we had it there from day one. But we're a little bit more focused on Java right now, but you can try out Kotlin if you know Kotlin. Scala is very new, so I've never actually tried it, but it's available. Just think of it as it's definitely preview. So what I'm going to do is I'm going to just select Spring DI and the Spring Web API, since there's a lot of Spring developers. And then you go off and you generate your application. Now, typically what you do is you download your application as a zip file and then you unzip it. But what I'm going to do is I'm going to push it to my GitHub repo. So I already, ahead of this, set up a GitHub token. So it trusts code.quarkus.io. And what I get now, so it's actually pushed it to my GitHub account, created the repo. I'm going to copy the command to the buffer. And then, here we go. I am just going to paste in the command. All right, go into the sfjug directory. And now I'm going to bring up IDEA, IntelliJ. I've been using Visual Studio Code. I'm relatively new to IntelliJ. Why I'm doing this in IntelliJ, I don't know. So please be forgiving if I do not know all the shortcuts quite yet. So let's take a quick look at the POM. We see we're Java 11, 1.7, and you'll see that we have REST Easy in there still. So REST Easy is pretty much always included as a JAX REST endpoint. But remember that we also added Spring Web, and a lot of the Spring Web support, remember, kind of maps to REST Easy actually under the hood. So I gave the auto-wired and inject example, and same thing with Spring Web. We actually map a lot of the Spring annotations to REST Easy under the hood. So, all right, let's take a look at the example code. So what you see here is actually just what looks like a Spring app, right? Pretty simple stuff. Let's bring up a terminal and run maven Quarkus:-dev. So Quarkus comes with a developer mode, and there's basically 3 modes out of the box. You're either running in production, which is like Java-jar, or if you compile the native binary, testing, right? So when you run a test, or dev mode is what we're going to be doing pretty much the entire time. So I'm going to start this up. It usually takes about 2 seconds or less to boot up in developer mode, but when you're running a Java-jar, it's usually under a second. Okay. And again, it's because my CPU is actually kind of pegged. Okay, here we go. So let's take just a little bit of a look at the output. So you can see it started, in this case, 3.5 seconds. Normally it's under 2. We have profile dev activated. So we're running in developer mode. And we've got live coding activated. That means that anything that we do is going to basically work on the fly. All the changes that we make. Oh, geez, and it wants to update. There we go. And we've got a bunch of our installed features, right? These are the extensions or Maven dependencies. So I'm going to use, so I don't have to scroll back and forth, a built-in plugin. That's a browser for IntelliJ, and unfortunately, it always goes to YouTube, and I can't figure out how to change it. So let's go to localhost :8080, and what you get is kind of this little static HTML page that tells you basically how, what to do next, right? It's just a static HTML. But let's go to the hello endpoint that we have in our code, and there we have hello. All right, now I'm going to scroll back and present. Go. All right, what we already know. We know Java, and I brought this up before. We know how to edit our code, package it, run Java-jar, refresh the browser to see our change, and if we got an error, or if it works okay and we're going on to the next feature, then we go through this whole thing again, right? And this can take, potentially tens of seconds. And sure, there's some Maven plugins or Gradle plugins that can kind of try to make this more expedient. But it's not going to beat what we can do with Quarkus. So with Quarkus, we have live coding, and we're already in developer mode. And all you do is you edit your code, you save the file, and you refresh. Now what I normally do, because I have multiple monitors, is I have one monitor open with an auto refresh plugin for my browser, and it just every 2 seconds it just refreshes. And then when I code, I just save the file, look over, and it just refreshes, right? So let's take a look at that here in a second. But it works with any IDE, right? Because it's running outside of the IDE. Right now it's running via Maven, but you can actually create a main method with Quarkus now. This came in the 1.6 release, I think. So you can create a main method and execute it by just saying run from the IDE, and it'll default to dev mode as well. Any code you changes is live. Any property files or static files that you change are reloaded live, and same thing with your POM. So I can go in and add and remove POM file or POM, Maven dependencies, and it's just going to work, right? Okay, so let's see here. Let's see. All right, so let's go back. Let's take a look at this really quickly. Let's do, okay, we have hello. If I just change this, no, don't want to do that, to howdy. Save the file, go over here, do a refresh. Now, before I do a refresh, look at the bottom window, because the way Quarkus works is it doesn't reload when you save the file. It reloads on the first request that it gets, right? So when it gets the request, it's going to say, hey, a file changed. Let me drop all the loaded class files for your application. So it doesn't reload everything like all the other libraries, just your apps code, and reloads it. And then since the JVM is all running, this all happens typically under half a second, right? So let's take a look here. Right, and see, in this case, the hot replace took 2 seconds. Again, normally it takes a half a second, so I'm gonna blame it on the CPU again. And the other interesting thing I thought I'd pick out, because I saw it scroll by this time. I thought I saw it scroll by, yeah, here it is. Vert.x worker thread. So this just shows you that it is actually Vert.x under the hood, right? So let's do one other quick thing. Let's try editing our code with some, some new annotations. So let's use MicroProfile config and just add a property. So I'm going to say name equals greeting, and I am going to inject this into a variable called greeting. Now, typically with MicroProfile, you would also have to add an inject annotation, but Quarkus, again, developer joy, tries to make things simpler. It supports it, but you don't need it. So I'm just going to leave it out for now. And we're going to inject in greeting, so we're just going to return whatever the greeting is, right? So I'm going to save that. Now, configuration in Quarkus is unified. So whether you're configuring data sources or any frameworks, like if you use Java EE, all of that stuff now is configured via the property file, right? Application.properties. It also supports microprofile-config.properties if you have that, application.yaml, and a bunch of external config sources as well. Okay, so let's do greeting. Oops, I didn't really want to do that. Let's go down here. Greeting equals prop hello. So we know it's coming from the property file. Let's do a save, come back over here, do a reload, and it says prop hello. So that time it took 0.7 of a second, but like I said, usually it's under a half. Okay, so we're getting lots of interesting things. Let's do one more. This time, we kind of have, in this case, a Spring Web endpoint. So this time we're going to use JAX-RS. So let's do new Java class, and we're going to call this JAX-resource.java. And we're going to add, let's see, at path. Let's make the path JAX. And we're going to use at get. So on an HTTP GET, we're going to call this method, and we're going to say public string. Let's just call it JAX. Doesn't really matter what we call it. And we're going to return. This time I'll just hard code it. JAX. Hello. All right, go back over to our browser, refresh the browser, and oops, meant to do JAX. And there we go, JAX hello, right? So what's really funny is, as you're going along, if you make typos and all this stuff, it doesn't really matter. It's a small penalty to pay, and you get this like insane iteration cycle going. All right, let's see. Now, what we already know, Java runs in containers. So I'm going to kind of move from some of the live coding stuff onto Java running in containers. So we know Java runs in containers, right? You can go to Docker Hub and see tens of millions of downloads of various JDK implementations, right? And, you know, I don't think this is a surprise to anybody. The problem is it does not run as efficiently as some other language runtimes. So I've been in multiple customer conversations where they've said, we're looking to move away from Java to another runtime. They looked at both Node.js and Go. And they did this because of the RAM utilization. They spent an awful lot of money on their Kubernetes clusters, and they were running, you know, Java stacks that were just consuming an insane amount of memory. So they were not getting the value out of their Kubernetes cluster that they paid for, and it was primarily due to the heap size being used by Java. So basically, I've been pointing these types of customers to Quarkus, and it is a game changer from this perspective. So why is Quarkus so much more efficient? Well, let's kind of start looking at how existing Java stacks, you know, single app stacks work, right? So we're not necessarily talking about traditional application servers, even single app stacks. So you got the Java virtual machine, you have an application server, which could be Tomcat, right? Let's use it synonymously for now. People pretty much deliver one app per runtime now. And you have a bunch of these dynamic application frameworks. So these are the same frameworks that we've been using for roughly, you know, for up to 20 years, right? Or at least 15. And they haven't really changed. So they are definitely very runtime dependent. They use a lot of reflection. And I think a lot of this is because these frameworks were designed initially to run in a Java EE environment, right? Where you had one JVM running lots of different applications, but the applications had different needs. So the applications themselves had to do things dynamically to figure out, you know, which parts of the code they wanted to load for which particular application, right? So this kind of created a lot of very dynamic frameworks, and there's a penalty to pay for that. Okay, and I am going to pause here and answer a question. Quarkus is supported from Java 11, or can it work on 8? It works on 8, but we're really trying hard to move up to 11. So with 8, there's an awful lot of enterprises that have standardized on 8 still to this day. So we don't necessarily want to leave them behind, but we, like everybody else in the industry, are trying to get organizations to move forward to Java 11 as quickly as possible. So we compile our libraries to Java 8. Our APIs use Java 8, but we do support Java 11. So I hope that answers that question. Okay.
So I imagine you try to aim for long-term support version to major long-term support version for your certifications?
Yes. So Quarkus is brand spanking new. So right now, with the current version of Quarkus, long-term is 6 months, right? So we do offer support on Quarkus, and I don't.
Sorry, I meant of the JVM. Sorry.
Oh, the LTS releases. Yes, we definitely target the LTS releases. So,
that's what I figured. Okay.
Sales pitch is out the door then. So yes, the LTS releases, although we do test intermediate releases, right? To know, to make sure we're not deviating from what's going on in the JVM world. So let's see here. And so what do frameworks do, right? Most Java frameworks in single app stacks do today. Well, what do? You build your app, now you got a jar file. So you boot the jar file, and what happens during the boot process? Well, it has to go look through its various configuration sources, load the properties, and then begin to configure how it boots everything else, right? So it also has to go through your class path and all your jar files, find all the annotated classes, and instantiate various beans and build a runtime model and bind all those beans that need to be bound, and create basically this runtime model. And after you do all that stuff, well, then you go ahead and you execute the application, right? So when I was talking about those startup times with Quarkus, it wasn't how fast does it start, right? Because I can start really fast anything if I add, ampersand to the end of the command line, right? So it's not really how fast it starts, it's how long does it take to respond to the first request. And so for Quarkus in native mode with a JAX-RS endpoint, I'm going from memory, it was like 42 milliseconds, right? So that's pretty quick. Now, Quarkus completely rethinks this approach to doing development. In a single app stack world, you and even running on Kubernetes, which we see as immutable infrastructure, right? So we look at it as you don't log into a container in Kubernetes to configure things. You reboot the application, right? So you make config changes and you reboot the container, right? And so in that scenario, does it really make sense to have all this work being done, this dynamic work being done at boot time, right? If we already know what the deployment environment is, right? So we've kind of rethought the problem. So with Quarkus, what we do, I'll actually talk about that here in a second, but first of all, we start with a similar stack. You have the Java virtual machine. And on top of that, you have these same frameworks, but they've been optimized for build time. Well, let me get to the next slide. I don't want to get too far ahead of myself, I guess. We optimize these same frameworks so they boot a whole lot faster, right? And then you run your app. So we're not just kind of gathering all this stuff that's been out there for 15 years and just adding, wrapping it with another framework. We actually optimize the underlying frameworks themselves, right? So JPA and Hibernate is a very good example. Will the slides be available? I can make them available. I can either put them on SlideShare or email them for wherever if you guys push something centrally. Okay, so how does Quarkus start? Well, all those things that I mentioned, it does at build time. So it loads the config files, scans annotations, builds this model. And what it does during this entire process is it actually records the bytecode that's being generated from all of this. And then as packaged into your jar, what you get is a static initializer of all the code that does all this work up front. That is, it's all done, and the results, so what's directly applicable to your application is shoved into a static initializer. So when you boot the application on kind of that red line, it's simply executing bytecode that is 100% directly applicable to your business logic, right? Because everything else has been scanned ahead of time. So we kind of call this compile time boot. So at compile time, we actually boot your application, record what's going on, and then shove the output into the resulting jar file. And it doesn't really take any longer than a normal Maven package would, right? And then we also optimize our frameworks for dead code elimination. So if you compile down to a native binary, Graal VM will do dead code elimination. So we make sure that we have these clean separations between various parts of the business logic. So we optimize for dead code elimination when running as native binary, right? So that isn't really shown here. So what this means, so what an extension does is it makes sure that your application, that the framework can be compiled into a native binary along with the rest of the application. So take a Java framework, again, like Hibernate, we made sure that it can compile to a native binary. And in some cases, that takes a lot of work, right? In some cases, it's very, very simple. In some cases, like with, I know some of you probably use Lombok, it compiles already out of the box to a native binary, right? So there's kind of this spectrum of effort depending on the framework. But we optimize it so it can be compiled down to a native binary. I mentioned we go through, we optimize it to remove unneeded dependencies so we can optimize for dead code elimination. With Hibernate, you don't have to configure things via a persistence.xml. You can do it via the application.properties file. So that means as part of building an extension, you can kind of support unified configuration, just one configuration source if you want to. And you could record the bytecode and if you want, and shove it into a static initializer. There's APIs for all this stuff. So we have customers now that are beginning to build and optimize their own extensions based on their in-house frameworks to take advantage of what Quarkus can do. Okay. Let's see. All right. Thanks, Bob. Said he's going to post it. And that's the -runner.jar. Yes. So when you package, in fact, I'll show you here in a second. So what we already know is how to deploy to Kubernetes. So we kind of talked about containers, how Quarkus optimizes for containers. But then what you have to do to deploy to Kubernetes is write just a ton of YAML, which I know you all probably just love to do, right? So what Quarkus can do is generate all of this YAML for you. So it will generate the deployment descriptor, YAML. It will generate health check probes to make sure, to verify that your application is healthy, and if it's not, restart. It will generate a service, and for that means basically it's exposing an internal IP address to the rest of the cluster, and a service account so that your application can run under a service account instead of your user ID, right? All right, so to do this, it's really simple. You just add one command to the command line, -d quarkus.kubernetes.deploy equals true. And it will take your application, generate all that YAML, and deploy it to Kubernetes, right? And it adds some nice, developer candy, I'll call it. And I apologize if you hear dogs barking. We create Kubernetes annotations for the git commit URL, so you know where the application is hosted, the commit ID, so you know exactly which version is running, and a build timestamp. We generate the health check probes, I think I mentioned that, and the services. Now, if with Quarkus, you can say, I'm going to deploy this to Minikube, so generate me YAML specific to Minikube, not specific, but optimized for Minikube. So it'll create a node port, right? We're probably just doing development. But if I'm going to deploy to OpenShift, then create me an OpenShift route, right? An external endpoint through an OpenShift route. So it does that. So let's see here. Okay, I am now going to go back to some code. Not that I have to. Do I want to? No, I want to show you something first. And then I'll go ahead and create a jar file. All right, so one thing I want to show you is, again, you can add extensions to a live running application. So I'm going to add, let's see here. I thought that would be a good one. Here we go. Maven add extension. We're going to add Kubernetes. This lets me, first of all, it generates all that YAML I was talking about, but it also lets me configure my YAML using just Java properties, right? So I can go in and customize the YAML that's generated by just adding a few properties to my property file. We're going to optimize the YAML for Minikube, and we're going to use the Docker daemon as well to actually create the image. We support Jib to create the image, and we also support S2I, since there's some OpenShift users on the line. I'm going to comment that out here for a second because I forgot to. Actually, I want to point to the Docker registry running inside of Minikube, right? So when I generate the image, it'll be already inside of my cluster. So there we go. Now I'm going to go back. And before I add an extension, I got to do one additional thing here. Which order do I want to do this in? I'll do this first. Okay, so what it's going to do is basically modify the pom.xml to add these extensions. So you can see now we have a Kubernetes extension, Minikube, and a Docker extension. And what I am going to do is do a quick time check here. One more step here is I am going to, I don't think I need to do anything right now. So I think with this, I'm just going to deploy it as is. So what I'm going to do is .deploy. There we go. Maven clean install. I'm going to skip test because it's going to fail because I think I changed it from hello. And deploy this to Kubernetes. So it is, I'm already logged into Minikube. And yeah, I am kind of pegged. Let me see what's taking up all my CPU. All right, I'll tell you what I'm going to do. For now, I am going to, where did I put it? Somewhere, oh, here it is. Stop my video. And let me turn off all the green screen stuff. Okay, hopefully that makes things go a little bit faster. Okay, so now we should have, let's do kubectl. I created a alias K for kubectl just because it's easier to type. So K get pods -w. Let's see what pods are up and running. And you'll see I've got a couple of native builds of this application. I told you I pre-built it to native just because it takes so long. And this is the application that we've just deployed. It's been running for 26 seconds. So let's run minikube service list. Let's get the endpoint. For sfjug, it is this one right here. Let's bring up our browser /hello, and there we go, prop hello. So we are up and running in Kubernetes. Now let's do something that's also really, really cool and go back to the presentation. So that's all it takes to deploy to Kubernetes. Oh, actually, one other thing I'll show you is, and I hope, I haven't heard anyone complain that the font is too small, so hopefully everything's okay. The Kubernetes that's generated, let's see, vi target /Kubernetes / you can see there's JSON and YAML equivalents of, well, our YAML of our configuration. And if I just bring up one of them in YAML format, you can just take a look at the YAML you want. You can even customize it, but just keep in mind that it gets overwritten every build. So you'd want to, if you want to customize it, you might want to copy it to a different directory. Okay, so, and I will also do a Maven, actually, target. This is the runner jar that somebody was asking, that Anthony was asking about earlier. It's the runner.jar file. So this is the jar file that you're gonna run. It's actually 341K, and all the libraries are actually in the lib directory. So when you build your Docker image, all of the lib stuff goes into one Docker layer and your application goes into its own Docker layer. So rebuilds are really fast, right? So that's why we do that. Can you create a self-contained Uber jar? Yes, that's a property. So you can say on the command line -d uber-jar or something like that, I can't remember. Quarkus.uber-jar equals true, and you can create a traditional Uber jar. Okay. So now let's do a little bit of Kubernetes fun here. So let me get rid of a couple of things. Oops. There we go. And it's a little bit bigger. What I can do is I've created some code snippets just to make this faster for doing remote development. So you set a couple of properties. What we're going to do now is we're going to remote develop against this application running inside of Kubernetes, just like we were doing it earlier locally, right? So I just define a new package type, mutable jar. I'm not going to get into that today. And to be honest, I'm not an expert on it, but basically it just sticks everything into a single subdirectory. So when it copies stuff remotely, it's all kind of encapsulated into a single directory. Okay, directory structure. So then we have a password. As you can see, it's just ASCII. We're bouncing around. Should we do something more secure? But for now, think of it as, well, we don't want, you know, if the two of us are developing to the same cluster, we don't want to accidentally kind of build or remote develop against the wrong instance, right? So you can create a password. Think of it as just a way to differentiate between pods running in the background. And then you got to set one environmental variable, and that is Quarkus launch dev mode equals true. So it launches Quarkus in dev mode. Otherwise, it would launch it in production mode. And what's really cool about this is actually that Kubernetes YAML customization I was talking about. So you got Quarkus.Kubernetes dot some Kubernetes object. In this case, it's or capability. In this case, it's environmental variables, the environmental variable name and its value, and that actually gets generated inside the YAML. So let's save this file, hit Control-C. Oh, I have to redeploy the application because it's going to regenerate the YAML and then push this application. So the YAML has to include the environmental variable, for instance, right? Okay, so that time it was much faster to actually do a Kubernetes deploy. So, okay, git pods-w, and we're already up and running. And let's now run it remotely in remote dev mode. Okay, so now 31697, 31697, right? So I have the URL, right? So it's just like before, Quarkus, Maven Quarkus :dev, this time it's remote dev. And we are now interacting with our cluster running inside of Kubernetes. So again, I can do hello. I can go to my source code. Here we go. Sorry. There we go. I had the Zoom icon bar kind of in my way, so I had to move it out of the way. Okay. Now let's go to our application. We'll go to the kind of Spring stuff. Actually, let's change the property file. Let's do it that way. Say prop, or this time instead of prop hello, we're going to say kube hello. Come on, ooh, that's why. That's not my source code. One too many over 0, prop hello to kube hello. Save the file, reload the browser, and there we go. And it actually gets a little bit faster. Hello 2, once it gets a little bit of JIT going, right? So hello 2. So now I can actually just do live coding remotely, just as if I were running locally. And what's really cool about this is a lot of times you would have to mock out all these endpoints while you're developing because the services that you need to talk to aren't necessarily exposed outside of the cluster. Well, now you can just deploy your application to the cluster, do development, and not have to do the mocking that you would have to do if you were running locally, right? And I could do some really cool things here. So if I go to the /health endpoint, and I might make this the last thing I talk about here because people are starting to drop off and we started late. So if I go to a health endpoint, you'll see there is no health endpoint, right? And what I can do is add, let's do small rye-health. Yeah, small rye-health. There we go. We're going to add the extension for small rye health, which is the MicroProfile health endpoint check. And you can see it's being resynced to our running server. And it's going to take a second to reload. I don't know if it's done yet here. There we go, and we're up and running with the health check endpoint now, right? So what about debugging? Yes, I believe you could also do remote debugging. I'll be honest, I haven't done it yet because I write bug-free code. And okay, I'm just kidding. But it might require you to then have a second node port, right, to expose the debugging endpoint. And to, when you do your remote dev, when Quarkus starts, I don't know if you can see it, it defaults to port 5005 for debugging. You would just say -d debug equals a different port number, right? So that works. Okay, other things I can do with Kubernetes is, we support config maps. We support, all the, open, the Jaeger support, metric support that you could tie into Prometheus and so on and so forth. Just asking for people who debug. Yeah. Pierre basically said, yeah, he writes bug-free code as well. We're part of the bug-free coders union. So I'm going to kind of switch back to code to the presentation. So the nice thing about this is you don't have to do all that, Docker efforts. Part of this, what I didn't show you, it was behind the scenes. There's also Docker files that are generated in the source main Docker subdirectory. There's a Docker file for native, a Docker file for JVM and fast jars. And then typically when you have to create your own Docker file, run the Docker commands to create the image, then you have to run kubectl, apply, and there's lots of extra work, right? So what do we now know? Having gone through this, you can pick the API framework that you want, and that you probably know, right? You can live code everything locally or remotely, which is really cool. This remote stuff works inside of Docker too, so it's not like a Kubernetes-centric thing. In fact, if you go to the Quarkus YouTube channel, you'll see the most recent video was Stuart Douglas, who basically developed all this live coding stuff, do it with Docker. And you get extreme runtime efficiency. I might do one last thing. And of course, we're talking about Kubernetes native Java here. So we're really optimizing this for containers and Kubernetes. And I'll get back to a couple of questions in the chat. One thing I wanted to show is that there's a conference coming up. It's free, October 13th and 14th. It was normally would have been held in Orlando, but it's basically J4K. So if you develop Java and you deploy to Kubernetes, this is a conference for you. Just go to j4k.io. I'm doing a presentation there that's different than this one. It is basically the top 10, or I don't know if it's top 10 or just 10 Kubernetes centric or Kubernetes native Quarkus features. You saw some of them here, but not all of them, right? So some Q&A. What about test hooks for those of us who don't always write bug-free code? For those of us that don't really have to test, for those of you that do have to test, is what I should say, there is, just to briefly show you, a test directory with some pre-generated tests. So it supports JUnit 5, and there's annotations for testing with Quarkus and JUnit 5. We use rest assured for endpoints. So you can see kind of a very fluent API for doing that. And let's see, that might be all I have to cover for now. Is there an IRC channel or Discord or Slack that people can ask questions? In fact, if we go to Quarkus.io, I want to show you a couple of things very briefly. These are good questions. And the Zoom bar keeps getting in my way. So if you go, we're already here. Darn it, we weren't there. If you go to the bottom, you can see that there's a chat room, and the chat room is Zulip. So we all hang out there. I'm there. The Quarkus engineers are there. There's a user channel for the people that use Quarkus. There's a developer channel for those that are developing stuff with Quarkus. I mean, developing Quarkus itself or writing extensions and stuff like that. So it's very active. Every day there's new questions coming up. One thing I thought I would show you is, given the time, I know I'm really pushing it here.
You're okay, John. I think with COVID, no one's going anywhere.
Yeah, definitely don't have to beat traffic, although it's too late for that anyway. Okay, so let's do a Kubernetes log or logs on this. And what you'll see is when this started, oh, that's the wrong one. Git pods. I want to look at the native version. So I have the native version running, and with the native version, and if you want, I could show you some of this stuff. I could show you config maps. I've got Panache, the Panache ease of use, like JPA layer running inside of this jug-native thing. So it's already pre-compiled in because I wasn't sure how far I'd get. But if I do logs on the native version, what you'll see is it started in 244 milliseconds, right? And normally this would start, you know, if I wasn't running all kinds of stuff, it would have, and it's actually, the entire Kubernetes cluster is running on 2 virtual CPUs, right? So it's not a highly tuned cluster here. It would normally start in, you know, 120 something milliseconds if you're running on a typical cluster with a shared CPU. And if you're on just running locally, compiled locally, it'll start in like 40 milliseconds, whatever. And this binary has in it health, support for config maps, for metrics, for this also includes connecting to the database. And so there's all sorts of stuff in there, and it still starts in like 240 milliseconds, right? And the other thing that we might be able to do is run into minikube SSH. Let's see what the memory footprint of that is. Of all that stuff, is I can run ps-o name PID. I don't think I need the PID. RSS pipe to grep application. It didn't work. Yeah, let's see here. PS. Why did that not work? I was doing this earlier. Does it not support PS? Yeah. PS-O. Sorry, quick check here. I'm cheating. PS-O, yeah, PID RSS command. Okay, maybe that's it. Maybe name. It's not name. PS-O, PID RSS command. It's command, not name. There we go. Let's do, how do I do this? See, the problem I ran into is PS-EF to kind of show everything doesn't seem to work in combination with, oh, I know what I can do. PS-EF pipe to grep application. Let's get the PID. Here we go. And now let's look at, try that. There we go. 128 megabytes, which is really big, but I was already kind of trying things out, so I kind of hit that pretty hard. So the RSS size went up, but you could run things like dash MX, you know, to set the max heap size and stuff like that. So typically, what you would see here is you know, like 50 or 60 megs. And what's nice is when you do this, you can run 10 instances of a Quarkus app for what you might normally do a single Quarkus, a single non-Quarkus app. So you get 10 instances running, scaling across 10 CPUs, and the overall throughput is going to be higher than what you have with your normal Java application, and you're using less RAM, right? So that's really cool. So we kind of have this metric that's megabytes. It's requests per second per megabyte. What's your throughput per megabyte? And that's really important for kind of from a Kubernetes perspective. Okay, let's see. Are there any other questions? And you know, if you want to, you can. Let's see. We do something here real quick. If you want to, you can, you know, unpop your video. Although I got to figure out which window it's on. I'm gonna stop sharing the screen.